So today we will be talking about the machine-to-machine communications, which is known as M2M communications. And later we will be talking about the next unit, which is about the software-defined networking. So first, machine-to-machine communication is a technology. It's based on a technology that enables devices to exchange information and perform actions without human intervention, right? M2M is a subset of IoT, right? So IoT, as you know, it is a network of devices which collect data and send that data across communication links to a local server, and then from there to a cloud, and then you make decisions at the cloud, and sometimes you bring back some feedback from the cloud to the devices, and at the device level also you can do computations and make decisions. However, in here, there's no control over the devices by humans. So in IoT, once the data is loaded to the cloud, the humans can analyze the data and make decisions based on the data. And based on that, they can try to, give feedback to the edge devices, sensors, or some controllers, and so on. So the feedback that is given by the humans is not available or not given in this M2M communications. So basically, M2M communication is a standalone communication which will be done without the assistance or intervention of humans. So because of that, this technology is basically used in situations such as factory automation, automatic meter reading, and so on. So in fact, factory automation, there are robots who, who will automate tasks. So if some tasks are done by the robots might connect with each other using communication protocols and make decisions based on the situation that they have in their environment. So they will rely on the communication that make with the other device. They will not rely on communication with the local server and a cloud. So M2M is a technology that does not rely on cloud computing. It will rely on the device level computing, right? So it will rely on device level computations and decisions that are made on device level. So factory automation is one such example. Another example is the automatic meter reading. In the meter reading will be taken by the sensors or the meter that is connected to the supply unit, such as electricity or water. And then those data will be automatically sent to a local server, where the local server will make computations on the amount of electricity consumed or water consumed, and based on that it will compute the water bill, electricity bill, and so on. So without any human intervention, the calculations are done. So the electricity bill is computed without the intervention of the human. It is already done by these machines. So the data that is sent from this machine is used at a local server or some other microcontroller, and it is used to do the computations and compute the bill value, and the output will be shown to the humans. However, the humans don't need to interact with the system to compute the bill or related data. So M2M communication is a subset of IoT. So it is, therefore, it is a kind of a simple communication system where the communication will happen directly between device to device level. And this communication will basically focus on doing the communication between these devices, right? So M2M is like a subset of IoT which focus on or enabling communication between device to device, and doing some activities, some useful activities based on the environment, right? So it might not need cloud resources and so on. So it might not need connection with a local, I mean, uh, like a network infrastructure or some other, I mean, resources which give them access to the core network and to the cloud and so on. They can work within their local area network. So they will have access to their uh, local server, and they will have access to other devices in the neighborhood, and they can do direct device-to-device communication. So an advanced version is the IoT. So IoT uses M2M communication, right? However, IoT has other technologies as well, and IoT can be applied for other applications as well. So therefore, we can consider that IoT is a much more broader uh, technology than M2M. So M2M is a subset of IoT, and therefore IoT has more features and application and applicability to different scenarios than M2M. So M2M is basically actually concerned about the communication between the devices, right? So next, we will also talk about cyber physical systems, which is another like a trending topic when it comes to IoT and related networks. So cyber physical systems is a more advanced term of IoT, right? Where cyber physical systems can automate complex processes such as self-driving cars, um, uh, fully automated industrial, I mean, robots, right? So self-working, self-automated robots. Uh, then, I mean, these self-automated robots are programmed to do some function, which is at the industry level, for example. Thirdly, we can take smart grid, right? So this figure shows application of smart grid and how we can use the cyber physical systems to operate a smart grid. So in there, actually, what happens is that the system at the edge of the network takes data and process the data at the edge of the network, right? So at the edge of the network, they do the computation and all the processing if required. And if required, it also send it to cloud-based services for storage and for other analysis, right? Apart from that, this system is able to make decisions about the future and the and take actions based on that. So in situations where we have complex processes, such as driving, for example, we can take decisions based on the real-time data we collect at the edge devices. So basically, this cyber physical system refers to an entire system of devices which are connected to internet and then the cloud, which is totally run by its own. That means there's no human intervention needed. Even at the cloud servers, the decisions will be made by the cloud servers itself based on the algorithm that has been designed for the system, and the decisions will be communicated back to the end devices if required, or else some decisions will be taken there itself, and some information will be taken out, uh, which would be useful for humans. However, in cyber physical systems, the human intervention is very minimal, and the total system will be autonomously run. The total system that contains a complex activity at the edge of the connection, and the access network and the cloud computing uh, cloud computing that is involved will all be run autonomously by the system. So the system will be programmed to work in a certain way autonomously based on the different scenarios at the edge device and where the edge device is situated. So um, likewise, so based on the complex process, the necessary step-by-step actions will be taken by the system itself autonomously, and the humans don't need to do any work, and they don't need to intervene in the system. The system will autonomously be controlled uh, by the cyber physical system and the algorithm that is designed for this system. So what if something goes wrong? So you might ask. So actually in that situation, there must be some uh, you know, some backup methods or hybrid methods proposed for the system in order for it to address like unexpected situations or mission critical situations where the system will not be able to take a decision. So anyway, currently cyber physical systems are under discussion and under research level. So it is going to be also a very emerging trend in the future. So therefore, people are actually researching about this and proposing new technologies that will be useful for the cyber physical systems. So when we discuss about the M2M communication, which is the topic of this unit, the M2M communication will happen at the edge of the device, edge of the network. So the M2M communication will happen, for example, between certain devices, right, within themselves. And once the devices have communicated, they can also access the M2M gateway, which will provide us the connection to the Ethernet or wired network, through which it will be able to access the uh, application of the process, right? So a certain process can be conducted, and that process is known as the application. And for that process to happen, certain actions need to be conducted. Those actions will be, I think, instructed by the application, and then such data will be communicated through the communication network, and then through that network across the M2M gateway, the devices will obtain the data. Based on that data, the devices will to work together in and communicate between each each other okay. So can you hear me? Right? If you can't hear me and if there's a loss in the voice, you can let me know. And also, if you have any questions, you can let me know. Then the communication network can either be wired network or a wireless network. So the communication can go through a wireless network of maybe base stations, and then it will reach the core network, and from there it will reach the cloud, and then we can reach the cloud-based application. Or else the M2M gateway could be connected to a wired network where we send the data across multiple routers, and the routers will be connected to the application. So this is a like a comparison between M2M and IoT protocols, I mean networks, right? So there are subtle differences between these two networks. So M2M networks can use communication protocols like Zigbee, Bluetooth, LoRa, Modbus. So IoT also can use these protocols, Zigbee, Bluetooth, LoRa. So Modbus is a protocol that is used specifically in industrial scenarios where device-to-device communication is done in industry using this protocol. So this Modbus protocol also can be considered as a IoT protocol. So since M2M is a subset of IoT, and then apart from those protocols in IoT, the HTTP, COAP, WebSocket, MQTT protocols are used. So these protocols are actually designed for like reliable communication, and for situations where we require access to the internet. So for such situations, we require these protocols: HTTP, COAP, WebSocket, MQTT, and so on. So in IoT, we have these protocols in addition to the M2M. And then when we consider about the network type that is used in M2M, we are actually doing communication between homogeneous devices. That means same type of devices. Whereas in IoT, we have different types of devices, different types of sensors, different types of microcontrollers, and so on. However, in M2M, we need to consider the same type of sensors or same type of devices, same type of controllers, and do the communication, because it is a less complex version of IoT. Therefore, it should be able to adhere to the less complexity in M2M, and homogeneous devices can work together easily. And therefore, I mean, M2M communications are mostly done in between homogeneous devices. So devices need to be of same type. So in M2M, actually, the functions communication in M2M rely more on hardware. However, in IoT, the communications and the data that is collected rely more on software. That means that in M2M, if there's like two robots, for example, communicate within each other, the robots will rely on the data that is collected across the hardware of the robots, and the data collected from the sensors, right? The sensors, which are the hardware of those devices. So they rely more on the sensors and rely more on the communication between the devices. So that communication will rely more on hardware. And the output of that communication will also be based on the hardware. So if there's some difficulty with the hardware or error in the hardware, the measurements that will be taken will be wrong, and then the total process might fail because of that. So therefore, it is very essential that the sensor functioning of the sensors are like monitored from time to time, and maintenance is done. so that the devices don't fail, and that we can actually have a very reliable activity done by these, self-automated robots, for example, right? However, in IoT, of course, most of the time, the device level, edge devices which are connected to the IoT network will collect the data, monitor the data as well, but it also has the ability to access the internet. So therefore it can upload the data to the cloud and do like complex computations at the cloud, and therefore it will rely more on software and decisions made at the cloud and so on. So therefore, in IoT systems, IoT will rely more on software and software-defined networks and so on. So data collection and analysis will be done locally in the M2M communications, where the communication will be done between the devices, and they will be making decisions based on the data that is collected. So at the local level, they will be communicating the data and making decisions based on that. However, in IoT, we will be sending the data to a cloud, and at the cloud, the computation will be done and the analysis of the data will be done. So most of the work actually can be done in the cloud in the IoT systems, whereas in M2M, the computation will be done on site and on device level. So the computation at the device level will be higher in M2M. And in IoT, we can actually do the computation in the cloud also. In application wise, we have for M2M, the M2M communication can be accessed by the on-premise subscribers. That means that the service or the M2M communication can be accessed by the devices which are in the neighborhood or the neighborhood environment where we are considering, such as, for example, industrial environment, right? When we consider industrial environment which is using M2M, we can consider that we can consider that the devices which are available in the environment and the site, right, industrial site, will be able to access the M2M communication and do the communication that is required. However, in IoT systems, the data can be accessed by any person on any place on the earth, right? Any person who's accessing the cloud can access the data which has been collected by sensors in another environment, right? So if the environment can upload the data to a cloud, the cloud can be accessed by any person on anywhere on earth. So therefore, in IoT, the subscribers can be staying anywhere on earth if the data is uploaded to the cloud. However, in M2M situations, the data will only be accessed and available to the devices at the premises. Okay, so those are the basic details that I wanted to share with you regarding M2M communications, so machine-to-machine communications. So if you have any questions, you can let me know. You can put in the chat as well. So next, I will be discussing about the next unit on network virtualization. So network virtualization is a very upcoming technology for the networks. So we require these technologies in our IoT networks, and therefore the IoT networks will also utilize these functions to upload data efficiently to the cloud and the cloud-based applications. So if you have any questions, you can let me know, right? So I will discuss content related to the software-defined networking, right? So first, let me raise a question, right? So how can we deploy large networks, right? Large networks with less cost and flexibly, right? Flexibly. Right? And securely. So so in this case, we will look at the traditional network, how it works. So the traditional network is composed of like multiple nodes and links, right? So once a person is requesting some services from server, the person, the person's request has to move from one server across multiple servers until the edge of the, I mean, end of the request, or until it reaches the destination node, right? So if it is a destination here, then data has to travel from the user end up to the destination across a huge network. So this becomes difficult once the network becomes large, right? So if the network becomes large, by the time the data packet request, or the request that we send will be sent as a data packet, the data packet will face challenges in reaching the destination, and it will be delayed because of the multiple routes from the source to the destination. So because of that, people have come up with solutions to this, and it is what we are going to talk today. So it is also known as network virtualization, right? So it will be a solution to reduce the complexity uh, and the insecureness and the costly nature of the current networks, right? So as I said before, once we have these like big networks, it's very difficult for us to send our data efficiently from one end source node to the destination node, right? So apart from that, once we use the traditional networks, the traditional networks are composed of servers, switches, routers, and so on. So they need to be configured every time. Once we want to make some change in the network, that will address some of the challenges that the network is facing. So in order for us to quickly update the network, we need a better solution, right? So currently in the traditional networks, the network is very rigid, and the infrastructure used is expensive. And updating, launching new products and services will take a lot of time, will involve long periods of time, right? So making changes to the network, introducing new products, new services will often take a long period of time because of the rigid nature of the network and the infrastructure that is used. So specified hardware are used for different functions, and therefore like once we try to add some new service to the network infrastructure, we might need to remove hardware and update hardware at each of the communication nodes, and we might need to change and update the hardware, which might be costly. So therefore, this is not feasible once the number of customers are increasing, and also once the network infrastructure is increasing with size, and with the amount of with the increase of infrastructure devices in the network. So basically, the challenges that the conventional network is facing currently is that the costly nature of the network, and the flexibility of the network is really low, right? So it is very difficult for the standardization process to happen. So once some devices are introduced by vendors, the operators need to form standards for certain equipments, and the communication that will be done using those equipments. So the standard, the process of making such standards takes a lot of time. So, so the vendors and operators need to spend a lot of time to standardize the process that is related to the hardware and the communication. And then the cost of it manufacturing the specific devices is high, and the agility of the network is low. That means the adaptability of the network for the network conditions is low, and the network management is difficult with the physically available hardware. Once the network is improving in size, increasing in size. So therefore, network management, configuration, and control are challenging issues in traditional conventional networks. So as a solution, network virtualization has been proposed by network engineers and experts in the field. So network virtualization is basically separating the software from the hardware equipments, right? So the concept virtualization means that separating software from hardware or hardware equipments. So in here, the network functionalities will be programmed using softwares. So the network functionalities will be programmed or coded as software files, and such software files will be included in the network, in the servers, and such softwares will be used to control the data traffic in switches and so on. So the softwares will be more used to control the network traffic rather than using physical equipment, so hardware equipment. So the network functionalities such as routing, firewalling, load management, packet forwarding control can be conducted using software, right? So in networks, basically routing of data packets happen, right? So once we take a condition where we are sending a request from one node to another node or another like server, right? So once our data packet is moving through this network, the network needs to perform different functions such as routing, right? Forwarding of the data from one node to another we call as routing, right? And the routing will be done across the best possible link using the routing tables, and that function is known as routing. And then we have firewalling, where we add a firewall before a certain network, such that like harmful attacks will not be sent to the certain network. And then load management, that means traffic management of the network. right, can be I mean, traffic management are some of the network functions done by the network. So these functions can be controlled by software programs, and these functions can be coded in software programs. So once we code based on the requirement of the network, how the load should be managed, how the firewalling must happen, how the routing must happen, then the network, that function, that specific function will be available in a software. Network function will be available in a software, and this software is a very agile thing. So this software can be installed in a virtual machine, and the virtual machine can take multiple softwares for different activities, right? We can take routing as one activity done by the software. Another software could be there for firewalling, that software. So it is another software. So this software can also be installed in a virtual machine. So certain virtual machine can be used to store the different network functionality based softwares and conduct those network functions. So the virtual machines can take more than one softwares that will represent network functions, and these softwares that we install in a certain virtual machine can be moved from one virtual machine to another virtual machine, and we can like dynamically change the network functions in the virtual machines. Okay, so can you hear me? Okay, you can hear me. So is it not clear to you? Is it clear now? Okay, sorry, actually I did not know whether you were not able to hear so far. Is it like that? So I hope it will be okay now. So can you hear me now? You can, right? So so I was discussing regarding the virtual machines and how the network functions can be included in virtual machines, right? So up to what point you were hearing? Did you hear up to this I mean this slide, or I mean you stopped hearing, I think, from previous slides? You did not hear all this from this unit 3 onwards? You did not hear anything? Can you let me know? I mean, from this slide onwards, you did not hear anything? Or you heard? You heard. Okay. So I hope you heard, right? So, okay. So I will continue. So if you have any questions, please ask, and I will answer your questions. We were talking about the network functions, and the network functions, most of the network functions that we want to implement in a network, such as routing, packet forwarding, load management, firewalling, and so on, can be done, can be implemented in softwares separately. I mean, this routing function can be implemented in a software that will include a certain code. and using that code, this function can be generated, the routing function. Packet forwarding also we can include in a software program where we code the necessary or the steps of the function. So after running the code inside the software, we can generate the function that we require. That is packet forwarding, right? So likewise, we can do load management, we can do firewalling, and we can actually save them as software files. So those software files can be stored in virtual machines, and these virtual machines can store multiple softwares in them. So routing function based software can be stored, firewall based software can be stored, and if there's another software based on load management, it can be stored, and so on. Apart from that, if the firewall has multiple commands, and if the firewall software cannot be saved in one virtual machine, part of the firewall software can be stored in one virtual machine, and the other second half of the firewall software can be stored in another virtual machine. So the firewall software, the rest of the firewall software, we call it number two, firewall number two, can be stored in another virtual machine, VM2, we can say. So VM1 will have one portion of the firewall, and the VM2 will have a second portion of the firewall. So once the network wants to have the total operation required by the firewall, the VMware 1 will have one portion, VM2 will have another portion. So depending on the task that is required, the network controller, there's another component called network controller. That network controller will decide which software to run first and which software to run second. So based on those commands, these softwares will be run in a certain sequence. Apart from that, if a certain VMware is, VM machine, that virtual machine will stop working, we can actually detect that, and we can also remove functions from that certain virtual machine and move those functions to another virtual machine, right? So therefore, we can actually flexibly move the softwares from one virtual machine to another virtual machine. Right? We don't need to do any hardware updates or hardware implementation. We can move the softwares from one virtual machine to another virtual machine. Okay, so these network functions are installed in a virtual machine. So the virtual machine is an application which allow us to run uh, like a server, and run a server virtually, where it has its own operating system and its own applications, and will exhibit the behavior of a server, right? Similar to a server, it will behave as a hardware equipment, and it will give the same functionalities of the hardware equipment related to servers, and then it will have the ability to incorporate applications. It has its own operating system, and it has the ability to install applications in that operating system. So we can also add our own network functionality softwares into this virtual machine, and we can run those applications in those virtual machines. So this process is known as the network function virtualization, right? Network functions such as routing and switching and load balancing, firewalling can be virtualized uh, by installing those softwares, network function softwares, in a virtual machine. So the total function will be operated in a virtual machine, and the softwares will be used to conduct the network function. So therefore, the total process will need minimal hardware. We will need some hardware also to save the, to store the necessary the softwares and the virtual machines. So we will need some hardware as well. This is not done totally virtually. However, the amount of hardware required is minimal in these kind of situations. Apart from that, as I said before, the same server can be used for several purposes. That means for several network functions, and it will depend on the software that is installed on it. So, so network function virtualization is one of the technologies of network virtualization, right? So network function virtualization means building or network, using softwares to generate the output of a network function, and using that software program to do the necessary task. So the network function will be stored as a software program, and it will be included in one or more of the virtual machines, and it can be flexibly moved in and out of the virtual machines. And based on the requirement of the network, the softwares will be controlled by the network controller, and the network function will be conducted. So basically, network function virtualization means the network function will be stored in a software program, and that software program will be stored in a virtual machine. And once we want to do that certain specific function, we call it as routing. If we want to do the routing, then we will call the software, and we will run the code in that software, and we will provide all the input data that is required for the software, and based on the data provided, the software will provide us the output that we require. And then based on the output, the network will do the routing as instructed or as given by the output. So that is how the network function virtualization is basically happening. So the basic idea is that softwares are used instead of hardware equipment to do most of the network functions. Most of the network functions can be written as software programs, and those software programs can be used and run in networks. And in those networks, we will be using virtual machines to run these network functions, and we will be giving necessary data to these softwares, and we will be getting the output from those softwares based on the network function, and based on that output, we will be doing the task. And then software defined networking is the second type of the or the second technology that is under network virtualization. So software defined networking is basically about controlling the data traffic between the virtual machines and between the virtual servers that we have built in the network, right? There's a certain controller that will control the traffic between switches or routers in an optimal manner, such that the the communication will happen very reliably from the source to the destination. So the communication can happen reliably from the source to the destination through a certain set of links, and the certain set of links or the certain route is decided by this main controller. So the main controller will decide along which route the data packets should be forwarded. So this controller is also defined using softwares, and therefore it is known as software defined networking. Right? So the controller is also built upon softwares, right? The controller is also having some hardware. However, in the hardware, we have software-based programs and protocols that will be run on the server, which is allocated for network controlling, and that server will send commands to the switches, and will understand the network topology, and based on the network topology, it will forward data in the optimal manner from a source to the destination point, source node to the destination node. So, so normally we use different algorithms to send our data from source node to the destination node. So that is using algorithms like Digistrar, A star, and so on. So these algorithms are used in traditional networks at each node of the network. Rather than doing that, the main software controller, network controller, will be able to have a global view of all the connected devices in the network topology, and based on all the available network devices, it will decide what is the best path for the data packet or the data traffic to move from one end to another end. So this is something I have already mentioned about network function virtualization. So the network functions such as routing, firewalling, load management, security can be done using softwares and software-based virtual machines. And it is possible to include different or multiple network functions in one or multiple virtual machines. And then network functions can be moved from one virtual machine to another virtual machine. Apart from all these things, hardware is also needed for the to cater the needs of the software. So, however, in this case, the hardware that is required are not like specific hardware. That means we don't need specialized hardware for this activity. We can use very low cost network hardware like switches, routers, and servers to do uh, this installation of network functions, and be used as one of the network function, virtualization based virtual machine, in that hardware. So we can run virtual machines in hardware which is readily available to us, or which are available to us in general, rather than going for specific hardware for a network packet forwarding. Then, I will be discussing about the SDN more in the next class. So anyway, I would like to mention that now the network functions that we have mentioned that should be installed in this virtual machines must be connected to the other switches and routers, and it should be connected to other switches and routers in the optimal manner, right? Only then we can send the data in a reliable manner without losing the data in the network, right? So we might lose the data in the network if we don't send the data across the optimal route from the source node to the destination node. So in order to find the optimal route, we need a centralized point which will give us directions about the routing path that is suitable for our communication, right? So all this centralization of the network controlling is known as software defined networking, right? So that is what we are going to talk in the next class, right? So software defined networking is a technology that will use a centralized mechanism to control the network, right? It will be a centralized controller that will control the network. So if there are multiple nodes that are connected to the network, there could be hundreds of devices. So the network controller will be able to contact all the specific 100 devices in the network and understand the situation of the network. Based on that situation, the network controller will decide what is the best method to manage the traffic in the network. Based on that decision, the network controller will give instructions to all the nodes in the network how to forward their own requests and data packets from their device to the other device. So therefore, the network controller is a centralized centralized controller, which will be controlling the network and network traffic. So I will be discussing about that in the next class. So thank you so much for joining today. So if you have any questions, please let me know. Also, I will be conducting the interactive classes on Thursdays and Fridays. You can ask questions regarding this lecture in that class as well. So thank you so much for attending today's class. I will end it now.